Hi, my name's Rahman Khan. I'm going to teach you how to use Minitab by taking you through a worked example from my book, Minitab Exercises for Greenbelts. By the way, that's available on Amazon. I recommend you work along with the example by downloading the dataset from my website, RMK Six Sigma, and by the way, that's free. All the details are given below. Let's go when you're ready. So this is number 2 of a series of 3 videos that I'm showing on Gage R&R. In the first video I also showed you how to download the dataset from my website RMK Six Sigma so you can work along. I'm not going to repeat that in this video, so if you need to see that again, please go back to the first video and have a look how to download the datasets. Otherwise just follow the link below. Exercise 8.02. You work for the Government Weights and Measures Department and have been asked to audit a measurement system used by Dodgy Dealings Limited to invoice customers. So as part of the audit, they have shared data on a Gage R&R study. This Gage R&R study was used to validate the measurement system and subsequent invoicing by Dodgy Dealings Limited. There's a clue there in the name. The study data is in worksheet Dodgy. So this Gage R&R study uses 10 parts which are randomly selected, designated A to J, 5 operators, Picard, Datum, Geordie, Writer, Bev, and each of those operators will conduct 3 repeat measurements, and we can use a historical standard deviation of 0.83 for this study, as recommended by Dodgy Dealings Limited. So it's your job to analyse the study and report results. Your report should include the following. Number 1, a gauge run chart. Number 2, estimate from the gauge run chart which is greater, reproducibility or repeatability. Number 3, estimate from the gauge run chart whether this is an acceptable, marginal or unacceptable measurement system. Number 4, run the Gage R&R routine using the assistant. Number 5, what's the breakdown of gauge variation? Number 6, is the measurement system at least marginal? If not, what are your insights to improve it? Number 7, is this a correctly executed Gage R&R that can be used to validate the measurement system? Again, we're split into 2 parts. One is around the gauge run chart from sections 1 to 3, and 4 to 7 are around the Gage R&R routine using the assistant. Let's get into that now. So here's my data from worksheet Dodgy loaded into a new Minitab file. As you can see, I've got 3 columns of data, and the name of each column is as described as the data contained within the column and the functions used within the Minitab menus for measurement system analysis. So I've got my parts, my operator and my measurements. As you can see, the first thing we need to do is produce a gauge run chart, so we'll do that now. So we're going to click on Stat, Quality Tools, Gauge Study, Gauge Run Chart. The menu opens, so our part numbers are in part, operators are in operator, and measurement in measurement. That's all we need to do. Click OK to produce the gauge run chart. So this is the gauge run chart. Our parts are on the x-axis, measurements are on the y-axis, with the mean of all measurements being given as the dashed line. Then we've got our 5 operators, Bev, Datum, Geordie, Picard and Writer. Can you guess the inspiration for that one? Let's start off with Bev on part A. So you can see her first measurement, then the second measurement is slightly higher, then her third measurement is significantly lower. So it looks like there's a lot of repeatability error there. And then because Datum is measuring differently to Bev, a lot lower, that's going to give us a reproducibility error. Then we have Geordie, who's much higher, then we have Picard in the middle, and then Writer kind of next to that. But there's a lot of variation between operators and within operators, and that's kind of true for every part. And then that leads us on nicely to the second part. So question 2 says, estimate from the gauge run chart which is greater, reproducibility or repeatability. Well, looking at that, yep, everyone has repeatability issues and there are reproducibility issues as well. But I'm guessing there are far more reproducibility issues because the range between operators is much greater than the variation within operators. So I'm going to guess that reproducibility is greater than repeatability. Part 3 that we need to include within the report is estimate from the gauge run chart whether this is an acceptable, marginal or unacceptable measurement system. Well, when you look at that, it's about one of the worst gauge run charts I've seen in my life. I'm going to guess that's unacceptable. Part 4 of our report needs to be run the Gage R&R routine using the assistant. So we'll do that now. So click on Assistant, Measurement System Analysis, and following the flowchart we want to run the Gage R&R study crossed. Okay, let's put in our 3 columns: operator, part, measurement. And if I remember correctly, the historical standard deviation that we want to use is 0.83. Click OK. We get a 3-page report, and I'll just set it up to zoom onto each page in turn. So now we've run the Gage R&R routine. Part 5 is what is the breakdown of gauge variation. For that we need to go to the summary report and have a look at the variation by source chart. So the total gauge error is 29.9%. Incredible. The repeatability error is 16.4%. and reproducibility is 25%. So I was correct in guessing from the gauge run chart that there was higher reproducibility than repeatability. Part 6 is asking us, is the measurement system at least marginal? If not, what are your insights to improve it? So from the variation by source chart and the decision bar, we can see the total gauge error is 29.9%. To be unacceptable, you have to be above 30. So this just comes in as a marginal measurement system. But let's see what we can do to improve it. So looking at the reproducibility operator main effects chart, to reduce the reproducibility, we would need to make the operators more aligned in terms of their measurements. So as you can see, Geordie's kind of the highest, and then Datum's the lowest, and the other operators are in between. So we'd have to figure out why there's a measurement bias between the operators and reduce that. To reduce the repeatability errors, we can look at the retest ranges and have a look at the operator ranges. They're all quite consistent in terms of their ranges. Looking at the breakdown of variation, there is no operator part interaction going on, so at least that's a bonus with this measurement system. Otherwise it is a bit of a complete disaster. So part 7, is this a correctly executed Gage R&R that can be used to validate the measurement system? So I've given you a clue in the name of the company. They're called Dodgy Dealings Limited. The question is, can you figure out what's wrong with this measurement system? So what we're seeing is a measurement system that's marginal, but it's looking absolutely awful. So I'll give you 10 seconds to pause the video and then see if you can figure out what's wrong. After that, I'll give you the answer. Okay, so time starts now. So did you figure it out? Why do we have a marginal measurement system when the gauge run chart looks so bad? Okay, let's have a look at the data to figure this out. We've got our measurement data. We took a historical standard deviation of 0.83. Let's see what we get from the data. So we can do that by producing a graphical summary. I'm going to go to Stats, Basic Stats, Graphical Summary of the measurement data. Click OK. So what we get reported, the standard deviation is 0.233. So the historical standard deviation that we were using is almost 3.5 times greater than the standard deviation of the measurement data. Let's run the Gage R&R again, but this time we will use the standard deviation from the data. Click on Assistant, Measurement System Analysis, Gauge Study Crossed. And click on the radio button for estimate from parts in the study. So we're not going to be using the historical standard deviation, but it's going to be working out from the parts in the study where we had a 3 times lower standard deviation. Click OK. Wow, look at that. So the gauge error is now 98.9%. When you look at the breakdown of variation, repeatability is actually 54%. And reproducibility is 82%. So the issue was that Dodgy Dealings Limited had given us a much inflated historical standard deviation for measurements. What that then did was improve our metrics for the Gage R&R study. But when you take the measurements from the parts and you get a lower study variation, it then unveils the true metrics for this MSA. So that completes this example. If you want to learn more about Minitab, you can subscribe to one of my many courses on my new website, thinksixsigma.com. You can also pick up a free 365-page Six Sigma Green Belt guide from my website, thinksixsigma.com. Let's continue to learn together. See you soon.